Hey guys, these are the guided notes for lesson 7. Just at the end, we still have circles to talk about. We've already talked about rectangles, squares, parallelograms, and triangles, how to find their areas. Today we're going to pick up circles, both their area and their circumference, which is just a fancy name for their perimeter. So this should not be a new formula for you. We're just going to probably use it in different ways. The area of a circle formula is pi r squared, meaning pi times the radius of your circle squared. And then the circumference, there's two formulas for it, and either one is fine to use. You could use pi d, which is pi times the diameter of your circle, or you could use 2 pi r, since if you double the radius, it's equal to the diameter. So as long as you know one of those, you should be fine, but get good at one of them. So the first example is number 13 off of your notes, because it does have a circle in it, but it also has other shapes. Now the first thing I should say, this is kind of poorly done on our part. There should be right angles here. This is a rectangle. You don't have to think, is it a parallelogram? It should all have right angles. So what I see in this picture is there's a rectangle, a triangle, and a circle. We want just the shaded area, so we need to add together the rectangle and the triangle, but we're going to take back out the area of the circle because it is not shaded. So let's think area of a rectangle is just base times height. I need two things that are perpendicular for my base and my height. One thing I want to point out, this 32 is the entire horizontal length at the bottom here. I only want the horizontal part for the rectangle. And if you look at the picture, the top notes that the top of the rectangle is 22 meters. We need to use 22 for our base, not 32. The height needs to be perpendicular to that, so we are going to use 20. We're going to use 22 times 20, so we're going to have 440 square meters for just the rectangle. Then we go to the triangle. Our formula for a triangle is base times height divided by 2. We're still going to have to know two things that are perpendicular. So I do see the 20 that's in this picture. We can use that since it's by the right angle that I forgot to draw in. But I need to know this length, and this length is still not 32. 32 is the entire left to right distance. We just want this part. However, we said the horizontal distance of the rectangle was 22. So if 22 of it's on the left, and then you go a little bit further to get 32, that amount would have to be 10. So I'm going to use 10 times 20 since they're perpendicular, and I'm going to divide it by 2. I'm not doing the Pythagorean theorem here because I don't need to know my perimeter. I don't need to know the slanted side length. You technically could find it, it's just not useful here. The area of our triangle is 100 square meters. Now for the area of the circle. The formula you just wrote down earlier is pi r squared. We need to know the radius of the circle. However, in this picture, we don't have any numbers at all for the circle. We don't know left to right how far across it is because we don't know this distance here to the left of the circle. We don't know the distance to the right of the circle. We just have this circle. So instead of looking left to right for a diameter or a radius, look top to bottom. We were told earlier that this rectangle had a height of 20. The triangle has a height of 20. So that means our circle has a diameter of 20. The distance from one edge of the circle to the other, going through the center, is 20 meters. So if the diameter is 20 meters, then our radius would be 10 meters. Now, when you put this in your calculator, some of your calculators are just going to square the 100 and put a pi after it. That's what I want to do right now. I don't want the decimal answer. Yes, I know it's approximately 31.4, blah, 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 blah. But I don't want to round until the very end of this problem. So all I did is I squared my 10 and got 100, and pi is just a number being multiplied, so I just multiplied it on the end, but I didn't put it in my calculator to get a decimal. Because we said we're going to take these three areas, add the first two, and subtract the circle. Of all these values I just wrote down, the first two are the only ones that are like terms because they do not have a pi on it, whereas the third one does. So we can combine the first two to get 540 and then just write minus 100 pi on the end. That's if the direction said the exact answer, the non-rounded answer. The in terms of pi answer is another way you'll see it. I don't want that. The direction said to the nearest tenth. Now put it in your calculator, and I would highly recommend you actually do this to make sure you know how to use your calculator. Type 540 minus 100 pi. Your calculator should tell you 225.8. Ignore this, I forgot to update this part here. It's supposed to equal 225.8 is your approximate answer. Do not use 3.14 It's not going to be a problem right now, but later on it will. Use your pi button on your calculator. Then turn to number 16. It's the next problem that goes over a circle. This one says, given the area of a circle is 25 pi square inches, find the circumference of a circle. Now, anytime in a problem I see the word area, I see the word circumference, I know I need those formulas. So that's my first step. Area is pi r squared. There are two formulas for circumference. I don't necessarily know which one I'm going to use, so I just wrote down both. The problem is here, they don't tell you the radius. They don't tell you the diameter. You cannot substitute in and solve for any of these right now. The only thing they tell you is the area. And I've said it before in class, and I'll say it a lot this year. If you're told area, or if you're told volume, or if you're told circumference, write down your formula to write an equation. We are going to substitute in 25 pi where you see A. Because now it's just an equation where all of these values are numbers except for the r. Pi is just a number. And if I'm trying to get r by itself, you can't get rid of the squared until you deal with the numbers out front. So if this had been like an 8, the first thing you'd think is, well, I need to divide by 8. It's a pi. So the first thing we need to think is I need to divide by pi. Conveniently for this problem, both sides of the equal sign have a pi, so they will cancel. This will not always be the case, it just happens to be today. So you just have a 25 on the left side of the equal sign, we just have an r squared on the right side. The opposite of squaring, when we're trying to solve the inverse of it, is to square root both sides. Don't forget that when that happens, you technically created two solutions. 5 is a solution to that equation, negative 5 is a solution to that equation. But negative 5 doesn't make any sense. We're talking about the radius of a circle. We're just going to have positive 5 for our radius. But that does mean we can now find circumference, because radius was part of that formula. So I'm going to use this one here with the 2 pi r. I'm going to substitute in my radius. And the directions aren't clear for this one. It will be much more clear on homework assignments and on quizzes and tests. It just says find the circumference. There are two versions of an answer we can get. And some of your calculators do the first version automatically, some of them don't. You just need to try your calculator and see what type you have. If you multiply just the non-pi numbers, so in this case just the 2 and the 5, you're going to get 10. That doesn't mean the answer is 10, because pi still exists. You're just thinking, though, 2 times 5 is 10, then times pi. If you just write 10 pi, that is considered the in terms of pi answer. You will see that phrase a lot in this class. It'll say, find the circumference in terms of pi. That means don't get a decimal, don't ever round, don't let your calculator give you an approximate answer. So a lot of you, that's going to mean don't push your pi button. Some of you, your calculator would be fine. Others of you, you can't push it at all. Then, if you actually type in 10 times pi, if you actually get your calculator to give you the decimal approximation, and I should have the approximately equal right there, that would be when the directions say rounded. That's when they say to the nearest tenth. Both of those are completely valid answers to this question. So I would want you to find both if it doesn't state the version. So find the circumference, we did, in terms of pi and to the nearest tenth. So the next one. A circular pool is surrounded by a circular sidewalk. The circular sidewalk is 2 feet wide. The diameter of the sidewalk and the pool is 26 feet. So before I even answer these questions, I need to make sense of what this picture is talking about. They tell us that the circular sidewalk is 2 feet wide. So anytime you're walking next to the pool, you've got about 2 feet before you either fall into the pool or fall into the grass. They also tell you the diameter of the sidewalk and the pool. So if you're going from one edge of the far side of the sidewalk all the way to the other side of the sidewalk, that whole distance is 26 feet. The first question is just, what is the diameter of the pool? That's the one that I have in the solid red line. Well, if we know that the whole distance is 26 feet across, and 2 of it is made up of sidewalk on the right, 2 of it is made up of sidewalk on the left, we just want to know, well, what's remaining that's not sidewalk? So if you take off 2 feet, if you take off 2 feet, you should get 22 feet for just the pool's diameter. Now we're getting into some area questions. What is the area of the sidewalk and the pool? What is the two-dimensional flat space that is taken up by the area and the pool together? So it's a circle. We're going to use pi r squared. But I'm talking about the sidewalk and the pool. This is the line I have drawn in blue. It's the whole thing. Well, if the sidewalk and the pool's diameter is 26. Oops, that's too fast. If the sidewalk and the diameter is sidewalk and the pool's diameter is 26 feet, we'd want half of that for the radius. We would use 13 feet for our radius. So I gave my in terms of pi answer. It's 169 pi. They didn't ask for the format, so I also got to the nearest tenth. In my calculator, I typed it in, I used the pi button, I got 530.9. If it doesn't state, I want you to find both in terms of pi and to the nearest tenth. Then it asks for the area of the pool. Well, the pool is also a circle. We just need the radius of the pool. The radius of the pool would be 11 because we said earlier that the diameter of the pool was 22. So half of your diameter is your radius. If I just take care of my non-pi numbers, if I just square 11, I get 121. So in terms of pi, the area of the pool, the area of the whole thing would be 121 pi. I said that backwards. I just realized my colors are all backwards. Sorry about that. That was supposed to be helpful. The area of the pool is 121 pi. To the nearest tenth, the area of the pool is 380.1. And those both should say square feet. Man, there's all kinds of issues with this one. Sorry. 18 should be a little clearer. This is the last one we're going to do here. The figure at right represents the overhead view of a deck surrounding a hot tub. What is the approximate area of the deck? So if you're fortunate enough to have a hot tub and a deck and you're trying to take care of it and you're going to go to Lowe's or Home Depot or wherever and you're going to buy stain for it, then you need to know how much you're going to buy so that you don't buy like 80 buckets of paint, or not paint, stain, when you only needed 3. So you got to know the area you're trying to cover. The thing is, the space you're trying to cover is this donut shape, and you do not have a formula for a donut shape. So use shapes that you do know. The whole thing, like if you filled in the hot tub with decking, is a circle. The hot tub itself is a circle. We just need to take the whole thing and take out the hot tub. So it's a circle, so we're going to use pi r squared. So we need to ask ourselves, well, what is the radius of the entire thing? So the entire thing would be the entire distance across, and that includes the 2.2 meter deck on both ends. So I have a 2.2 meter deck on the bottom, 5.4 meters to get across the hot tub, and then 2.2 meter deck at the top. If I add all 3 of those values together, the diameter of the whole thing is 9.8 meters. The formula doesn't want diameter. It needs radius. So I'm going to cut that in half. The radius of the whole thing would then be 4.9 meters. So I'm going to use that in my formula. The directions for this one eventually say approximate area, so I'm not even going to plug that in. I'm going to now go deal with the hot tub. The hot tub was the value of 5.4 meters. So just the hot tub is 5.4 meters. That is the diameter. Do not put that in your formula because it asks for radius. So half of 5.4 would be the radius of the hot tub, so the 2.7. Again, I'm not going to round until the very last step. So to find the area for our deck, we're going to take the area of the whole thing minus the area of the hot tub. I'm going to I'm going to type that entire line in my calculator. Pi times 4.9 squared minus pi times 2.7 squared. I don't need an in terms of pi answer, so I'm just going to get an approximate answer. This time I did to the nearest hundredth, 52.53 meters squared. So make sure you're watching the directions. If it says approximate, you don't need to worry about in terms of pi. Sometimes it'll only ask in terms of pi, and if it doesn't state, you need to practice doing both. So the practice that is on your class calendar for this goes over rectangles and squares and parallelograms and triangles, and then it has circles. So it's kind of a mixture of everything. Make sure you're watching the directions. On numbers 2, 4, and 6, it says also find the perimeter. But on the odd problems, 1, 3, 5, you can only find the area. It won't be possible. There's not enough information. And I'm pretty sure just like yesterday's, if you're doing Pythagorean theorem on those, you're doing more work than you need to. They should be more straightforward than that. So give those a try. Re-listen to this video if you need to. But hopefully that'll be enough to get you through circles. And good luck.